Okay, so the last thing we want to look at in our unit on quadratics is solving a quadratic inequality. All right, so to solve x squared minus x is less than 0, we're going to start by approaching it like it's an equation, not an inequality. So we can factor this. We have a GCF here. We have a GCF of x. So pull out that GCF, and it factors as x times x minus 1 less than 0. Okay, so if this were an equality, an equation, we would take each factor and set it equal to 0, which just gives me x is 0, x minus 1 equals 0, add 1 to each side, and x is 1. Okay, but at 0 and 1, that's where this expression is equal to 0. We want to know where it's less than 0. Okay, so what we're going to do, we're going to draw a number line. I'm going to put 0 and 1. These are called our critical points. Okay, at 0, the value of x squared minus x is 0, and at 1, it's also 0. Okay, so now I want to check the intervals between 0 and 1, and also left of 0 and right of 1. So I want to check down here, over here, and also over here in each direction from the critical points to see whether our expression is positive or negative at that point. So less than 0, of course, we're looking for when the expression is negative. So let's try left of 0. I'm going to try negative 1. So we'd have negative 1 squared minus negative 1, which is 1 plus 1, which is 2. So at negative 1, we're at positive. Okay. Let's try another one to the left. Negative 2. So we have 4 plus 2 is 6. Okay. And we're going to see you can keep trying values to the left of 0. We can try negative 3 as well, but we're always going to get a positive. Let's try the right side. Let's try right of 1. Let's try 2. So it's going to be 2 squared minus 2, which is 4 minus 2, 2. So we get a positive there. If I try 3, be 9 minus 3, 6. Positive, of course, okay? So we know left of 0, the function is positive. Right of 1, the function is positive. Sorry, expression, not function. We also have to test between 0 and 1. So I'm going to try 1/2. Do 1/2 squared minus 1/2. Again, I'm just plugging 1/2 into there. So 1/2 squared, 1/2 times 1/2 is 1/4 minus 1/2, and 1/4 minus 1/2. Multiply this by 2 times 2, so we got 1/4 minus 2/4, which is negative 1/4. Okay, so in between 0 and 1, it's negative, which is what we want. So x is going to be, the values of x that work are, and in your answer, you're going to give it as a graph. It's going to be 0, 1. You should remember from inequalities that if the equal sign isn't there, we leave the circles closed. Open. And then we know everything between 0 and 1 works. So your answer looks like that. All right. Let's make some more room over here. So for number 2 factors x minus 3 times x minus 1. We're looking for greater than 0 here. So the critical points for x is 3 and 1. Okay. So I'm just going to write x minus 3, x minus 1. It's a lot easier to substitute into the factored expression rather the expressing with the squared, the quadratic expression. So 0, 1, 2, 3. At 1 and 3, the expression is equal 0, right? So let's test first to the right of 3. I'm going to test 4. So that's going to be 4 minus 3 times 4 minus 1. So that's 1 times 3, which is 3. So to the right of 3, the sign is positive. Let's do to the left of 1. So I'm going to try 0. That's going to be 0 minus 3, 0 minus 1, which is negative 3 times negative 1, which is positive 3. So we have positives to the left of 0. Now we want to test between 1 and 3. So I'm going to test 2. That's going to be 2 minus 3 times 2 minus 1. It's negative 1 times 2, which is negative 2. So we got negatives in between. Okay, so what's going to work? This is going to work. So we want to know where it's positive, right, greater than 0, as well as this, okay? So your answer is going to look like, when we draw the graph, 0, 3, both of these get an open circle, and this gets a left arrow, because everything left of 1, sorry, this should be 1, not 3. I mean, not 0. And then everything right of 3 will work. Okay. Number 3 is already in factored form. From the factored form, we know the critical points are 3 and negative 5. Okay, so we'll make our sign diagram. 0, negative 5, 3, and it's equal to 0 there. Okay. All right. So we have x minus 3 times x plus 5. Let's try to the right of 3 first. So we'll substitute in 4. That's going to give me 1 times 9, which is 9. So it's going to be positive to the right of 3. To the left of negative 5, we'll try negative 6. That's going to give me negative 9 and times negative 1, which is also 9. And then if I try in between negative 5 and 3, we can try 0. So that's going to be negative 3 times positive 5, which is negative 15. It's going to give me a negative in there. Okay, so I want to know when it's less than or equal to 0. Well, it's equal to 0 here, it's equal to 0 here, and it's less than in between them. So the values that work is what's in the highlighted section. We draw our graph for our answer, negative 5, 3. It has the equal sign in the problem, less than or equal to, so the negative 5 and positive 3 are both getting filled in circles, and we are shading in between. Okay. Number 4, we need this to be set equal to 0 on the right side, so we'll add 24 to each side. X squared plus 10x plus 24 greater than 0, which factors as x plus 6, x plus 4, greater than 0, so that means the critical points are x equals negative 6 and negative 4. Okay, do a sign diagram, negative 6, negative 4 are equal to 0 over there. Okay, so if we go right of negative 4, we'll have negative 3 plus 6. I'm going to fix that. So we have negative 3 plus 6 times negative 3 plus 4. That's going to be 3 times 1, which is 3. So to the right of 4, we're positive. To the left of negative 6, let's try negative 7. And negative 7 plus 6. Negative 7 plus 4. So that's negative 1 times negative 3, which is positive 3. And then we need the middle. So we'll do negative 5. So we have negative 5 plus 6 times negative 5 plus 4. So 1 times negative 1, which is negative 1, which means we're negative over there. So the question asks, when we're greater than 0 or positive, it's going to be that and that. So our answer, negative 6, we'll get an open circle, left, negative 4, get an open circle as well, and right. Okay. Now we want to graph inequalities involving parabolas. So I want to graph y greater than or equal to x squared minus 6. Okay. The only issue is we need to look out whether we have the equal sign. Just like before, if we had the equal sign, it was a closed circle. If we didn't have the equal sign, it was an open circle. Well, if the graph has an equal sign, it's a regular connected parabola. If it doesn't have the equal sign, if we just have greater than or less than, the graph is going to be connected with a dashed parabola. All right. So number 5, we're going to act as if this were y equals x squared minus 6. Okay. So you should remember this is in standard form. Want the vertex. That's it, and x equals negative b over 2a. For this one, b is 0. It's missing the x term. That's going to be 0 over 2 times 1, which of course is 0. And then to get the y value of the vertex, we'll substitute 0 into the function, which is negative 6. So the vertex is 0, negative 6. Okay. Then we want to get some points in one direction. Then we can get the other side of the parabola using symmetry. So we'll do a t-table. So when x is 1, y is 1 squared minus 6, which is negative 5. So we have 1, negative 5. When x is 2, y is 2 squared minus 6, which is negative 2. Over there. Okay. Then we can use symmetry to get the values at negative 1 and negative 2. Negative 1 we're right there. Negative 2 we're right there. And since this has the greater than or equal to sign, we're going to connect as we normally would. Okay. There's our parabola. Now we want to test points both inside the parabola and outside. So inside, I'm just going to pick a nice point inside the parabola. I'm going to pick 0, negative 3 right there. And we'll substitute in, see if we get a true or false statement. So we have y greater than or equal to x squared minus 6. So negative 3 greater than or equal to 0 squared minus 6. Negative 3 greater than or equal to negative 6. Is that true or false? It is true. Okay. Let's test the outside of the parabola. A point that is clearly not along the parabola, not inside of the parabola. I'm going to do 2 comma negative 10. So y greater than or equal to x squared minus 6. Negative 10 greater than or equal to 2 squared minus 6. negative 10 greater than or equal to 4 minus 6, negative 2. Is negative 10 greater than or equal to negative 2? No, false. Okay, so you can test any point inside the parabola. It's going to give you a true statement. Any point that's outside of the parabola is going to give you a false statement. So to depict that, we're going to shade inside the parabola. All right, so for B, we need to keep in mind this is just a less than, so we're going to connect our parabola with a dashed parabola. All right, so this is in standard form again. So we want to start with the vertex. That is x equals negative b over 2a. So that's going to be negative 8 over 2 times negative 1, which is 4. We get the y coordinate of the vertex. We'll substitute in 4, so it's going to be negative 4 squared plus 8 times 4 minus 20. So we got negative 16 plus 32 minus 20. So we've got 16 minus 20. Sorry. Yeah, 16 minus 20, which is negative 4. So the vertex is at 4 comma negative 4. All right. Now we can get some points to the right and then get points to the left using symmetry. We'll make a t-table. Okay, 1 point, 1 unit to the right of the vertex. Remember we're talking about x values is at 5. So y equals negative 5 squared plus 8 times 5 minus 20. So 5 squared, 25, negative 25 plus 40, positive 15 minus 20, which is negative 5. So we have 5, negative 5 over there. And then let's try 6. Y equals negative 6 squared plus 8 times 6 minus 20. So 6 squared, 36, negative 36 plus 48, 12 minus 20, negative 8. So we have 6, negative 8. Okay, negative 6, negative 7, negative 8. We are down here. Okay, and then we can add our other points in from symmetry. We have 3, and then 2 over there. All right, so again, this is going to be a dashed parabola because the sign is less than. So we're going to connect it like that, okay? So now we need to figure out which way we're going to shade, if we're going to shade inside or outside the parabola. Let's try something inside. Okay. So our inequality, y less than negative x squared plus 8x minus 20. Good point to test. Let's test for negative 5. So negative 5 less than negative 4 squared plus 8 times 4 minus 20. Negative 5 less than, we got 16, negative 16 plus 32 is positive 16 minus 20, negative 4. All right, negative 5 less than negative 4. Yes, that's true. Let's see the outside. Okay. Good point to use. Point that's going to make things really easy. 0, 0. So we'll get 0 less than 0 squared plus 8 times 0 minus 20. 0 less than negative 20. That's false. Okay. So the outside gave me a false statement. The inside gave me a true statement. So again, we're going to be shading the inside of the parabola. And of course, what that means is if I take any point inside the parabola, such as, I don't know, 5 comma negative 7 or negative 3, negative 8, okay, and I substitute into the inequality, it's going to give me a true statement.